Hey cool cats and kittens, welcome to day 3 of our experiment for the rubber egg. So coming to you live from my basement. So let's start with our observations. So for day 3 we're going to write our observations. Notice that there's still some bubbles forming. Remember the solid that we have formed around on the edge is our calcium acetate. And the bubbles are, as we learned yesterday, from the breakdown of the carbonic acid into carbon dioxide and water. So when you take a look at our experiment, you can start to see that there's quite a bit of yellow forming if you're looking at the top of it. So again, sorry, I'm not the best at videotaping, but you can see that it's quite yellow. So if I were to actually start to scrape the bubbles off, I'm going to actually feel that there's no membrane left. No shell left. So we can say that all of the calcium carbonate has been broken down into calcium acetate and carbonic acid. The carbonic acid has turned all the way into carbon dioxide and water. So we're not going to do the next step yet because we need the next step to occur. Sorry, we're not going to do another procedure to it yet because we need the next step to occur. And having the membrane having the vinegar go into the egg through the membrane is important for our next step. So we'll talk about why that happens. So let's come back to our equation. So yesterday we talked about the acetic acid in a double replacement reaction with the calcium carbonate giving us a solid calcium acetate and carbonic acid. Step 2, the carbonic acid is in equilibrium with carbon dioxide and water. We also spoke about how this is similar to why a pop goes flat. So just to talk about something that we know, and it's very interesting for the Easter theme specifically, is that when dyeing eggs, people often use vinegar to help the dye come in. So this is perfect for Easter time. So when we're talking about Easter, a lot of people dye eggs, and sometimes you'll put crayon on areas that you don't want dyed. Now the reason why that area doesn't get dyed is because of the fat in the wax. So wax is a non-polar substance and it won't be touched by the vinegar because vinegar is polar. So things that are different don't dissolve in each other. So for those of you that were following along with the emulsification lab, that is why the egg yolk emulsified with the oil and the vinegar turning it into an emulsion, which is a term to explain a homogeneous mixture that has become a colloid, basically meaning that it doesn't separate anymore. So in Easter, people use vinegar to soften the egg a little bit so that the dye is able to be permeable and penetratable into the shell. But remember, if you use too much vinegar or soak it for too long, you're going to get a rubber egg like this. So we haven't talked about why it becomes rubber yet. That'll be tomorrow, which is day 4 of our observations. So let's look at the net equation. So number 1, we started with acetic acid. I think pink is easier to see. So acetic acid. And that was aqueous, and we combined it with calcium carbonate, which was the solid, and we got a double replacement reaction to get calcium acetate and carbonic acid. Okay, step 2, the carbonic acid breaks down. So we get H2CO3, and that's in an equilibrium. That's why we have the backwards arrows. And that's turning into carbon dioxide as a gas and water as a liquid. Now let's go to my first equation. I forgot to balance. I have 2 acetates over here. So I need to throw a 2 here to make 2 acetates over here. So 2 applying to this. And then I don't need to worry about this hydrogen because there's 2 here. I've already taken care of the 2 there. So it's balanced. Now, a net ionic equation is when you take what goes in and what comes out. So my reactants and my products. So because carbonic acid is a reactant and a product, we cross it out of our formula. So what we're left with is 2 moles of acetic acid plus calcium carbonate will break down into calcium acetate and carbon dioxide and water. Okay, so the question may be is, could you drink all of this then if we don't have any acetic acid left? And the answer is no, because we put an excess of vinegar in here, there is still going to be some vinegar remaining, okay, and that has to do with equilibrium. Basically, once all the calcium carbonate has been used up, we don't use up any more acetate, okay, so whatever is not used up is going to be an excess reagent, so the excess means there's extra, so there's still extra acetic acid in here, okay. So, until tomorrow, take care, guys.